Sweet. Hey, everyone. My name's Liesl. I'm the CEO and one of the co-founders at Essential, one of Archetype's portcos. And yeah, I'm going to be chatting today about intents in general and the declarative design patterns that we're seeing in Web3, how Essential is working with declarative design patterns, and also how it sort of differs from the way that some other projects are working with it. So yeah, to start off, focusing on imperative and declarative programming as separate paradigms inside and outside of the blockchain space. So imperative programming, the sort of computer scientists among us will understand, is a paradigm that expresses how a problem should be solved through explicit instructions. So the developer is providing a sequence of like commands or statements that perform operations step by step. So the focus is really on the instructions and less about the actual outcome. The outcome is sort of like a secondary effect of what the instructions say. And the alternative is the declarative programming model. So languages like SQL and Haskell, for example, that express what the program should accomplish rather than how. So it's really focused on outcomes. The developer is expressing what the program should accomplish, like the objective of it, without saying how that necessarily needs to be achieved. So the focus is on outputting a valid outcome regardless of the specific instructions that were input. So in today's sort of blockchain landscape, all blockchains are essentially imperative, and it's the prevailing paradigm in blockchain development and has been so since sort of at least the advent of Ethereum as a general purpose smart contract chain. And so the way that users interact with these imperative blockchains is via instructions, so usually in the form of a transaction or smart contract, like opcodes that are being called, instead of declaring their desired outcomes, which is a declarative approach. And so I'm sure we've all seen the vending machine analogy for smart contracts. The idea is basically it's a simple self-enforcing form of contract where the machinery of the vending machine itself can enforce what the user and what the vendor want to do. And the philosophy is this idea of like automatic execution of a contract. So you remove the need for a trusted intermediary, and that the contract can be executed without some sort of counterparty or agent on the other end actually being present and engaging in the performance of the contract. And the idea originally behind this is it's supposed to execute unambiguous code when certain conditions are met, and then you don't need to wait for this agent. But even though the code execution itself is unambiguous, that sort of masks the fact that imperative smart contracts leave a huge amount of room for ambiguity in the way that they're structured, because they focus on instructions rather than outcomes. When things go awry or don't go in the way that's planned, you can get a lot of unintended consequences. So to understand this a bit better, let's go deeper into the vending machine analogy under the imperative model. So let's say that you go over to a vending machine and you want to buy a bag of Doritos. So you walk over to it, you select whatever slot that the Doritos are in, let's say it's slot A2, and then you put in your money. And so at this point, this is the equivalent on-chain of having initiated a transaction. But tragedy, while you're waiting for your order to be processed, someone comes along, opens up the back of the vending machine, and replaces all the stock. So there's no more Doritos now. All of a sudden, the items have been replaced with Coca-Cola or something else. So what's happened here is that this person was able to change the state of the vending machine after you'd submitted your transaction, but before it has actually been executed. So now, when the instructions are finally executed, you don't actually end up getting what you wanted, but the crucial thing is you technically get what you asked for, because in this model, there is no concept of being able to actually ask for Doritos. You just have to take an abstraction of that, which is item in slot A2, and hope that the state of the chain matches what you anticipated when your transaction is executed. So in this way, the imperative system has a sort of concept of a state between state A and state B, and during this intermediate state, when execution is happening, things can change, not necessarily always in the way that users want or expect. And so we all know this as the dark forest, right? It's originally kind of came across as an unintended or unexpected side effect of imperative blockchain design. But today, for the people who make money exploiting this, it's actually no longer a bug. It's kind of become a feature. And there's currently sort of an entire sub-industry dedicated to, tinkering with the vending machine in order to extract value from end users who have very little power over changing the system. And so we kind of think that this shouldn't really be possible, and it's not intended behavior either. Even the Ethereum yellow paper says that users should be able to interact with the system with absolute confidence in the possible outcomes. That was always the intention, but it's not quite what has come to pass. And that word outcomes is key because it ties back to the declarative programming paradigm that we were thinking of before. So if this imperative blockchain paradigm that I'm talking about has so many limitations on users and developers and networks, then why aren't we taking a different approach? We actually kind of already are. So starting in even as early as like 2018, a lot of people in the Web3 community had already started talking about things like declarative smart contracts and looking at declarative approaches as an alternative to make sure that outcomes are what is preserved in the system. But even though this has been discussed occasionally over the years, it never really gained significant traction until starting in early 2023 when the intent narrative started to pick up some steam. And so, as I'm sure most people in this room already know and have heard in the talks today, the sort of core ethos and principle of intents is this idea that users can sign over their intended interaction in terms of the outcomes that they want and not the instructions. So declarative rather than imperative, and that's how intents sort of fulfill this declarative model. But intents as a primitive are being applied in a number of different ways, including within very imperative-focused systems. So most intent projects are still turning these outcomes that users express back into instructions in order to settle. So basically, because they're using imperative blockchain systems, even if you as a solver are able to ingest an intent, ultimately what you have to output in order to settle that intent is something in the form of a transaction, opcodes to be called instructions, and not something that's declarative. So really, these projects and parties are still all working under the sort of vending machine model. All they do is allow the user to get somebody else, like a solver, to engage with the vending machine on their behalf. But the risk of losses and all the unintended consequences that come from that fundamental model still apply. It's just a matter of who's the one who's accepting those risks. And so a lot of teams are already making significant progress here in mitigating and managing those risks, and specifically making sure that they're passed along to solvers rather than to the end users. So that's already a good way of mitigating the limitations that the imperative blockchain design introduces. But ultimately, we kind of think that there's a better way to do this at a lower level in the stack. So if we can't defend the vending machine against the people who want to exploit it and its users, then what do we do instead? Well, we think that we should just get rid of the vending machine entirely, right? The solver ecosystem has cropped up in the context of originally just application-specific intent projects, but it's growing very quickly. So now that we have all of these agents that are sitting there waiting to enforce contracts and to connect counterparties, why don't we use them to just directly fulfill users' intents and get rid of the vending machine model entirely? So with that sort of philosophy in mind, we introduced the concept of declarative blockchains. You've seen intents being applied at the level of applications specifically, like for swaps, things like CalSwap and Uniswap X, and then obviously with presentations like Nix, so you see the next level of the intent primitive being applied to a cross-chain context. But ultimately, like I said, these are still within an imperative blockchain environment, and we're looking at taking intents and applying them sort of the next level down in the stack, which is at the state machine level itself. So declarative blockchains, by definition, leverage constraints, which is a sort of declarative term, to achieve state updates without the need for execution. And so this means that there's no intermediate state between state A and state B, because there is no execution or computation that's actually happening on chain, which means that there's no one that can come in and sort of tinker with the vending machine in between the time that you submit whatever it is that you want to do and the time that you actually get settlement. This means that basically state is updated atomically, so you get straight from state A to state B. And this is because we don't really have a concept of execution, either in protocol or really even out of protocol. What actually happens is because we are able to use the declarative constraint-based paradigm, you can skip the execution component entirely and just use the blockchain to record and validate new state without actually computing it. Okay, so how do declarative blockchains work? Sort of throughout the entire flow of the declarative blockchain, there are declarative or constraint-based components that are being brought in. So the first step is a user submits their intent, which is a declarative format. It's basically constraints on state that they own. So they can say, this is the state that I own, this is what I want to happen, and these are the rules or limitations that I'm applying. And then the only solutions that are actually valid are the ones that fulfill those outcomes. So that if a user signs over instructions that don't necessarily fulfill what they want to do, they can't achieve any outcomes that they haven't otherwise already consented to. So this is kind of similar to the user flow in the current model in the sense that right now most users interact through like web UIs. You click some buttons, you say, this is what I want to happen. And fundamentally, like your experience on the user side is pretty much the same in the sense that you're just saying, this is what I want to happen. But the difference is what happens once you click the approve or sign button. Is that being turned into a set of instructions in an imperative sense, or is it being turned into an intent that's framed purely in terms of constraints and outcomes? So then the next step, sort of down the stack again, is that smart contracts in a fully declarative blockchain system are also declarative. Rather than being sets of instructions or algorithms, they are just sets of rules or constraints. And so smart contracts just basically say, these are the circumstances in which a new state update will be considered valid, and these are the circumstances in which they won't. And so if you think of something like an AMM, for example, they're very declarative in nature by default. Like the constant product function is really just a set of rules about how balances can be updated and what balance needs to be applied when that happens. And so as a smart contract developer, you can consider that you can create those rules and not have to actually understand the idiosyncrasies of the underlying VM in order to also create a set of instructions that make sure that those rules get followed. So it sort of takes an additional step out of a lot of the mental arithmetic that comes to being able to develop smart contracts on a chain. And yeah, the final sort of next level down is that the state machine itself is declarative in nature. And basically what this means is solvers provide their solutions directly as state updates rather than as instructions to be executed on chain. So solvers can ingest intents that come from users and propose them in the form of solutions. Those solutions then get ranked and aggregated. Obviously, there are a number of different models that you could use for maximizing utility and doing sequencing and ordering. But ultimately, you can have a competitive network of solvers who are aggregating various different solutions, looking for liquidity across a variety of different ecosystems, and then ultimately proposing what they think is the best solution for that intent for the user. And because they're proposing their solutions directly as state updates, you don't need an execution VM on chain. All you have to have is a constraint VM that's basically responsible for checking the constraints and ensuring that the new state doesn't violate any of them. And so this is a lot more efficient than running all of the execution on chain because you're just validating that the outcomes are correct. So it's a lot more lightweight and a lot more like an actual distributed ledger. Where if you think about a ledger, what's really important is what's recorded and not how you actually get from the one entry to another. And so it's taking the most important parts of what we really want blockchains for and leaving them on chain while removing the additional stuff and taking it out of protocol. So yeah, computation on chain has been necessary up until this point to ensure that we can all agree that a new state is valid, but this provides an alternative method for reaching agreement that a new state is valid according to what the user and smart contracts have dictated. So yeah, a little bit about what we're building at Essential. We are building a declarative layer 2 on Ethereum that, like I said, has no concept of execution in order to update state, but rather just a constraint checking VM. So it's a rather different development environment and model. It sits sort of in the modular stack where an execution layer would, but obviously without the execution component. So it's another way of determining how to achieve new state. So because of the fact that we've sort of adopted this new model, we're not building on any other roll-up stack or existing VM, but rather are an entirely new sort of roll-up framework. And so developers in this environment will build applications using Pint, which is our declarative domain-specific language. It stands for Programmable Intents. And basically, yeah, it's a fully declarative language, and all applications written in Pint will be intent-based by default, because they do just express constraints. And so we'll get all of the benefits of being an intent-based application without necessarily having to specifically write something for an intent-based platform or audience. So yeah, we're starting to onboard the first sort of cohort of builders into Pint. So if anyone is interested to learn more, I'd love to chat to people afterwards. And yeah, we'll be at ETH Global San Francisco next week, sponsoring the hackathon. So would love to see some builders there. But yeah, other than that, would love to have people check out the docs, get involved, challenge us in some of these ideas, and figure out how we can work with some of the projects doing similar things in the space. Yeah, that's all. Happy to take some questions.